Okay, so blood, when you transport it, blood vessels, it's the highways for the blood. The heart, it pumps the blood. So the heart specifically is about the size of your fist. Pumps oxygen-rich blood to the body, oxygen-poor blood to the lungs. Okay, so it's made up of cardiac muscle. We've talked about cardiac muscle before. Red versus blue, I've already talked about this. The way it's not actually blue, it's just we refer to it as deoxygenated. Okay, so two systems, pulmonary and systemic. Okay, so our heart has four chambers. The atria are two at the top. It receives blood. The ventricles are two at the bottom. They pump blood. The septum is the wall that separates them. That's really, really important. We need that separation so that we don't have the mixing of oxygenated and deoxygenated blood. Probably a question on a test. So, the vena cava, as we already drew in our picture, is the blood vessels that go into the back to the lungs, or the heart, and they go into the right atrium. Here's all the definitions. I think we should just draw it because this is just a lot of words. Okay, and then skip to the valves. We'll just talk about the valves and then we'll draw stuff. Those are just the definitions of where they go, but I'm going to show it to you in a diagram. But if you like words, you can go back to it. Okay, okay, so four valves. Atrioventricular valves, so atria, ventricular, so it connects the atriums and the ventricles. Atrioventricular, okay? There's two of them. It separates the atria from the ventricles. The right side is called the tricuspid valve, and the left is called the bicuspid, because the tri has three flappies and the bi has two flappies. The other type of valve is the semilunar valves. They're called semilunar because they look like two half-moon shapes. They separate the ventricles from the blood that they're pumping out to from the body. This is a picture showing an idea of things, but I don't like it. Okay, so here is our blood flow. So say, let's start with the blue coming in. So here's the vena cava. It's coming in from the body, deoxygenated, pumps out. It pumps out the aorta. No, it pumps out the pulmonary arteries. Let's start again. Okay. Pumps out pulmonary arteries to go to the lungs, comes back in, pumps out to the body. Okay? Goes to the lungs, comes back, goes to the body. Comes back in, goes to the lungs, comes back in, goes to the body. Okay? So it's essentially just this, right? Comes back in from the body, needs to pump out to the lungs, and comes back in. So keep the big picture in mind. Okay, now we will draw it together. So we'll go into all of the details in one drawing. So do you want another piece of paper, or do you want, you can just draw it on the back? Who wants another piece? Okay, so now we will draw the heart. Am I going too fast? No. It's okay. So normally I would have stopped here for a day. But now pretend like you've gone home, you've memorized all of that, and now we're doing the second part. I guess I don't have the smartboard thing where you just circle it and hit it to go away. Okay, good. We're about on time. All right. So going to simplify things a little bit. So, 1, 2. And I drew this one a little bigger on purpose. And then 1 and 2. There were 4 chambers in the heart. What were the 2 on the top called? Atria. So I'm going to say I'm going to call this RA for right atria and LA for left atria. Because it's like when you look at a heart, right? You would look at the left side, right side. Okay? So you can make a little legend and say RA means right atria, and LA means left atria. Okay. Now what are the things at the bottom called? Ventricles. So here is RV for ventricle. I might draw them a little closer. Just this one a little closer. So RV and LV. So RV is right ventricle, and LV is left ventricle. Now, everything that I'm doing, you need to memorize. So, you know, when I'm trying to memorize the heart, I don't draw it in like, I wouldn't draw it like this if I was trying to memorize it. That's way complicated. I would draw it like this. Draw 4 circles, RA, LA, RV, LV. Okay? As long as you know what that means, that's good. That's simple, right? Okay? Don't overcomplicate it. Now, in your notes, it said that the vena cava empties into the right atrium. So we're actually going to draw, there's going to be 2 big vessels that empty in, because the vena cava, there's a top and a bottom part of it. So this is called the superior vena cava. So superior means higher, so it's above. And this one is called inferior. Inferior vena cava. So superior is something that's above, and inferior is something below. So the vena cava drops in from both sides. So why? What did we say on our last picture, what the vena cava was? Go to your last picture. What was the vena cava coming from? The body. And remember, the body is composed, we have a top of our body and a bottom of our body, right? So the superior vena cava is everything from our top of our body coming in. So everything that is above our heart empties into the superior vena cava. And then everything below our heart empties into the inferior vena cava. So that's why there's 2. Because it needs to drop in from 2 sides, okay? Now, so the blood comes in, and what color is this blood color? Is it deoxygenated or oxygenated? Deoxygenated. So let's draw the blood coming in. So the blue blood, or the deoxygenated blood, comes into the right atrium. Now it needs to go, so it kind of pools up here, and then it needs to go into the right ventricle. How does it get there? It needs to go through a valve. I'm going to use green to represent valves, just to have something different. So I'm going to draw kind of, I can draw 1, 2, and 3. It doesn't really look like that, but I'm just drawing 3 to represent the 3 flaps. So this is called a type of AV valve. Specifically, which type of AV valve? The tricuspid valve. The tricuspid valve. Now, if this blood is deoxygenated, where does it need to go? What does it need?
Lungs.
It needs to go to the lungs because it needs oxygen. So it needs to go out through a vessel. So right now it's stuck in the right ventricle. So it needs to go out into a vessel. But in order to get through that vessel, it has to go through another valve. This valve is called what? This is a semi-lunar valve. And we just call them semi-lunar valves. There is more specific words for them, but I won't tell them to you now. So it goes through a semi-lunar valve. So now the blood, when that valve opens, goes out into this vessel. So now this vessel will actually branch off. I'm going to show it branching behind. So it branches off. To go somewhere. So the blood follows. And it's going off into 2 different places. Over here, it's going to the left lung. And over here, it's going to the right lung. So it needs to go there to get oxygen. Okay, so that's what's happening with the right side of the heart. Now, once that blood gets oxygen and comes back, it's going to come back into the left atrium. So the left lung and then the right lung. I'm just going to kind of show you this, okay? So it comes, there's actually going to be 2. Oh, I guess I should draw them as black and then show the red coming in. So here's my vessels, or my arteries. Okay, so blood comes back from the lungs and goes into the left atrium. And it comes in from 2 sides because I obviously have 2 lungs, so it pours into 2 sides. So just like with the vena cava, I had a top and a bottom that needed to empty in. With my pulmonary veins coming back in, I need 2, I have 2 on 2 sides because I have 2 lungs. So these, think about it, these are oh, we forgot one thing. What did we call these? They're going away from the heart to the lungs, so they're called? Good, yeah. So this was a pulmonary artery. And over here too. Pulmonary artery. Okay. But now when it comes back from the lungs to the heart, what do we call these? Pulmonary, what's your guess? Veins, yeah. So now it all pools up in the left atrium. But now it needs to go to the left ventricle. In order to do that, it has to go through a valve. This valve separates an atrium from a ventricle. So it's called an atrioventricular valve, right? So this is another AV valve. And specifically, it is the bicuspid valve. Spelled that wrong. I think I was spelling biscuit or something. Okay, so now our blood is pooled in our left ventricle. So I drew the left ventricle bigger because it is bigger. Why do you think? Remember always, the structure of something always equates to the function of that something. So why would the left ventricle be so much bigger? It has to pump more blood because all throughout the body, yeah. So it's going to pump a lot more blood. So what we also need to label here is that we have a lot of muscle, because it's going to have to pump to the whole body. So we need a lot of muscle there that will help. Pumps to whole body. So when we do a dissection of a heart, you'll see, but here, so here would be your left ventricle, so it's much thicker, and when you see the muscle, it's like this side is really thick. So from like here to here, the wall of the heart is really big and tough because it's so much. So even see from this side, you can see this is the left ventricle, and here's the right ventricle. It's so much bigger. Okay, so much bigger. And then up here, these little chambers are the atria then. Okay. All right, we're almost done. Okay, so now we have blood pooling in the left ventricle. It needs to go to the whole body. Which thing does it go out of to go to the whole body? It's one very special type of vessel. What came out of the heart? Look at your other diagram. What came out of the heart that went to the whole body? Aorta. Aorta, yes. So it needs to go out of a vessel. So we'll draw this kind of going behind. And then I'm just going to erase these. You don't erase them though. But you want to draw a big vessel coming up. Big, big, big. Really big. Okay, and on the top of it, draw vessels coming out, arteries coming out. So I'll just draw mine lower and show you what I mean. So with your aorta, draw it big and have vessels kind of coming up. Say this is the aorta. So, in order to go into the vessel that pumps that out, though, we need to go through one more valve. And again, that's called the semilunar valve, so I'm just going to put an arrow to my one label already, and that's the semilunar valve. So this goes out the aorta, pumps to whole body. Okay, so that's the whole heart. Now, how do you approach even memorizing this, right? There's a lot of stuff going on. I'm going to show you a couple tricks. How do you memorize this? You need to literally write it out about 20 times, okay? If, though, it takes you about one and a half minutes to write it out once, that's only about a half an hour, and you've memorized the whole thing. Don't sit there and stare at your textbook for a half an hour. You have to write it out yourself. I would say about 10 to 15, even 20 times. So I'll show you how to do it, because you don't have to go into every single detail, but you need to do it in a way that will help you. So you always do it quick and dirty, okay? So you draw 4 chambers. RA, LA, RV, LV. You don't have to write this down, you can just watch how I do it. And then I would go valve, valve. That's my AV, and it's the tri. Here's an AV, and it's the bi. Done, okay? Then I think to myself, okay, what happens on the right side? All right, I have an emptying into the vena cava. So I'm just gonna put vena cava, okay? Comes in, goes through. Okay, if it's deoxygenated, it needs to go to the lungs. Pulmonary artery goes to the lungs. Oh, forgot my last valve here. Guess I should draw the actual thing. Okay, one more valve. Semi-lunar goes to the lungs. Comes back to the lungs. Pulmonary vein goes through the left atrium, left ventricle, needs to pump out to the whole body. Aorta needs to go through another valve, semilunar. Done. Okay? So you don't have to draw absolutely every detail, and you don't have to write out the whole term every time. If you can remember that AV means atrioventricular, then don't write it out the whole time every time, because that will take like an hour. But you don't, if you only have a half an hour to memorize the heart, sit down and draw it out 15 times. Yeah, okay? Don't make it harder for yourself. Sitting down and drawing it 15 times is hard, but it will take you a lot less time to memorize it than if you just stare at your textbook for a half an hour. Okay? That won't help. Now, one other thing that I want you to draw on this picture, so just draw it a little bit onto the side if you have a bit of a side. There's one other thing that I need you to memorize with the heart that's very special. Okay, so just one other thing. So just draw, what we're going to do is we're going to look at the outside of the heart for a minute. So just draw a heart. I guess you could draw it like this. Okay. So I want you to look at this model that's kind of falling apart, but oh well. There's something very special happening on the outside. What can you see is going on the outside? Like, so there's all this brownish, like paint or whatever. But what's this drawn on the outside? Okay. What are those? Capillaries or something? Okay. Arteries and veins, right? But they're drawn on the outside. Why?
It's blood too.
needs blood too. Why?
Because it's a muscle that needs oxygen.
Because it's a big muscle itself. So it needs delivery of oxygen and taking away of carbon dioxide just like every other muscle in the body. So it's like, don't leave me out. I need some oxygen too. So when we think about the heart itself, it will have arteries and veins attached with it. Now you don't need to know very specifically every single thing here or where they are exactly. But there's one very, very special artery that kind of comes in and delivers all the oxygen. And this is called the coronary artery. Coronary artery. So this delivers O2 to heart muscle. Because just as Connor said, the heart is just a muscle like everything else. It wants that oxygen as well. So when you hear about something like a coronary bypass surgery, it's doing surgery on the coronary arteries that are on top of the heart. Because if the coronary artery gets plugged and it stops delivering oxygen to the heart, we have major problems because then the heart can't function like the muscle it's supposed to, so then it won't pump. If the heart's not pumping, it's not delivering oxygen to everything else. So when our coronary artery has problems, we need help right away. And that's when you hear of a coronary bypass.